Okay, so welcome everyone to Lancaster University's Data Science Institute Distinguished Speaker Series. For those of you who may not be familiar with the DSI, our aim is to support interdisciplinary research relating to data science, and that includes both data-intensive research and what we might call more critical data studies, looking at some of the challenges posed by techniques and applications of data science. The DSI also aims to work collaboratively with external colleagues and partners to tackle key issues, which we've grouped into various themes, for example, health and environment. We've got Nigel Davis here, co-director of the DSI. You can give a wave if you like. There we go. And for those who don't know me, my name is Brent Knowles, and I lead DSI's society theme. And in the society theme, we explore contemporary concerns around trust, accountability, and ownership of data, and how data science impacts different stakeholders, such as government, civil society, public institutions, business and industry. And some of the cross-cutting topics that we're particularly interested in within this theme are inequalities and trust in AI. And the talk today, I think, actually speaks to both of these areas in a way. So I'm sure we'll have a lot of people looking forward to hearing what our speaker has to say. So it's great that so many have joined us here today. Many of you will already be aware of our speaker and his work, but he deserves a proper introduction, I think. So we're delighted to welcome Brent Mittelstadt from the Oxford Internet Institute at the University of Oxford. And Brent is a leading data ethicist and philosopher specializing in AI ethics, professional ethics, and technology law and policy. He's also the coordinator of the Governance of Emerging Technologies research program, and he leads the Trustworthiness Auditing for AI project. So in addition to having co-authored a number of highly influential publications, works that have inspired me personally in my own research, such as Explaining Explanations in AI and Counterfactual Explanations Without Opening the Black Box. His work has also made important contributions to policy. And for this, he's twice received the O2RB Excellence in Impact Award. And these impacts include legal analysis of the enforceability of GDPR's right to explanation, developing requirements for what could be considered meaningful explanations, and developing metrics to detect bias in AI systems. And hopefully he'll correct me if I've gotten any of that wrong. So today, Brent is going to be speaking with us about bias preservation in fair machine learning, hopefully helping us to understand some of the finer details of non-discrimination law and what it means for AI. And he's going to be talking for about 45 minutes or so, followed by some time for questions. So if you have a question, jot it down, put it in the chat as you think of it. And I'll try to monitor that, keep track of questions for when we get to the Q&A. Just a quick reminder, sort of housekeeping thing, if you could make sure that your mic is turned off so we don't have any background noise. That goes for everyone who's not Brent. And with that, I'll hand it over to you.
Great, thank you so much. Let me just get my screen shared here. Is that showing up okay?
That's great.
Okay, fantastic. Well, thank you so much for the introduction. And yeah, I'm happy to say everything was accurate. It was a very good synopsis of the work I've done. I might steal it from you in the future. So yeah, as you mentioned, I come from the OAI and work with a number of people in the Governance of Emerging Technologies research program. And just to explain a bit about what GET, as we call it, is, because it's been behind most of the work that you mentioned in the introduction. Essentially, it's a group of people that come from ethics and philosophy, from law, and from computer science. And now also we have some colleagues that come from psychology. And we work at the crossroads of those disciplines. And we do a lot of work around emerging technologies. Of course, AI and machine learning is sort of the top emerging technology of recent years. So a lot of our work focuses on that. And what we're looking for is essentially, we're trying to solve governance problems. We're trying to solve problems like, how do you explain black box systems? How do you explain them in a way that's meaningful to people that are not experts in machine learning. How do you test systems to make sure they're not biased or they're not being discriminatory? And we do that from the perspective of ethics law and computer science. So essentially what we're doing is coming up with solutions where they should be ethically sound or ethically good, they should be legally compliant, and they should be technically feasible. And we've had some good success with the specific issues of explainability and opacity in machine learning and AI systems, and increasingly also on the bias and fairness sides of things, which is what I'm going to talk about today. And as you mentioned, I am a philosopher by background, but I find myself talking about the law quite a bit. That's actually what I'll be talking about predominantly today, which is European non-discrimination law, which is also still the basis for UK non-discrimination law, and basically how you can match up or bridge the gap between technical work on fairness in machine learning and AI and non-discrimination law, and also, to be fair, US anti-discrimination law. So the talk today is based on two papers, and the first one I'm going to start out with is the one that shares the same title as this talk, which I published with my colleagues Sandra Wachter and Chris Russell, who I publish with very frequently. And essentially in this paper, we were looking at the sort of huge array of fairness metrics or ways of measuring fairness that have been proposed in technical work on machine learning and seeing how well they lined up with the fundamental aims of European non-discrimination law. And this paper is published, it's freely available, happy to send it around after the talk too, if that's helpful, but easy. If you just search the title, find it pretty easily. So to set the scene here, so the problem I'll be focusing on today. So bias and fairness in automated decision-making, in machine learning, in AI, these are problems that have been very intensively researched over the past several years. And the problem is essentially this. So we have systems that learn from data about the world. And because they're learning from data about the world, they also inevitably learn from the biases and inequalities that exist in the world. And if we're not careful, they can replicate and exacerbate those biases and inequalities, as well as create entirely new, novel, emergent biases and inequalities through their decisions, through their recommendations, through their outputs. Now, fixing bias is often treated as simply a data problem. So the idea here being that to create neutral or fair technology, what we need is more data, more representative data, about the environments in which we will use the system and about the people that the system will work with or help. In other words, we just think about this as if we get better data, we can fix the problem. But it's not that simple. It's not just a problem of getting the right data to be able to train a neutral model. If we add more data to our training data sets, the data sets we're using to train machine learning models and AI systems, the decisions or the outputs of those models will, of course, paint a more accurate and nuanced picture of the unequal world that we live in. But by adding more data, making the data more representative, we're not going to resolve the root causes of inequality and bias in the world. Of course, we're not going to. It's just a technical fix. Only individual, societal, or institutional change can actually solve those root causes of inequality and bias, of course. And that's a feature of many of the technical fixes that are deployed in the field, what I'm going to call the field of fair machine learning. Essentially what they are is a temporary fix for the symptoms, but not the causes of inequality in society. And so in that situation, you're left with sort of three possible responses to make machine learning and AI, I'm just going to refer to it as AI for this talk, to make AI systems fairer and less biased. So the first is that we can do nothing and just allow things to get worse. So that doesn't require any sort of active choice. Just failing to take bias or fairness into account when we're designing, training, and using these systems is enough to accomplish that. That sort of non-intervention amplifies and widens the existing inequalities in our society that have been learned by the system through exposure to data that accurately reflects biases and inequalities. The second path we can take is to try to rectify what we'll call technical biases and essentially maintain the status quo to ensure our systems don't make things worse. I call that second option just don't make things worse than they currently are. The third path is that we can acknowledge the fact that the status quo is typically not a neutral starting point for most people, and instead try to use AI, try to use machine learning to shed light on existing inequalities and potentially help fix them or help at least relieve them to some extent. And that sort of analysis, that sort of statistical analysis of bias and inequality in the world and in the systems we create, can serve as a starting point for technical remedies and policy interventions that help fix historical biases and inequalities going forward. Now, to date, much of the work on fairness in machine learning and AI has taken that second path, that just don't make things worse path. What we considered in the paper and what I'm considering in the talk here today is how that goal of just not making things worse with AI is actually reflected in the technical work on fairness in machine learning, and also how that aligns with the fundamental aims of non-discrimination law. As a philosopher, I always have to define my concepts before I talk about them. So what do we mean by bias in data science, machine learning, AI? So we can think of bias in the first instance as a neutral concept. It's really any expression of a preference or judgment can be said to be biased insofar as it is subjective. So bias is really unavoidable at some level. If you're making any sort of judgment, any sort of preference, that could be considered biased. Now, machine learning exists to make judgments or to classify new cases. So based on that, based on the intended use of the system, we can say that it is inherently biased. But again, that's not necessarily a bad thing. It's more of an unavoidable thing. So the reason we can say that is because the systems we're talking about learn from examples. They generalize from training data. They find patterns and characteristics or general rules to help classify new cases or just to help analyze to deal with new cases. And so to minimize bias, the first thing or the minimal thing you can do is to provide these systems, these models, with good examples to learn from, or a set of samples that are sufficiently large, diverse, well annotated, well labeled, and representative of the types of cases that will actually be encountered in the wild or in the production environment. And ideally, that data, that training data, should also be reliable in terms of accurately representing ground truth. So the problem is that machine learning is only as accurate and reliable as the evidence it is given or trained on. Where bias exists in the world and where it's reflected in the data we use to train these systems, we should expect it to be reflected in the outputs of the model and the systems that we design. If we teach machines using data that is biased or inaccurate or non-representative, we should expect biased and inaccurate models and decisions. And there's a basic distinction here to be drawn between statistical biases and normative biases. And there's a whole range of statistical biases, which if you take an introductory course to statistics, you'll be well aware of. I'm introducing this distinction only to say that what I'm focusing on in this talk is not statistical biases, but rather normative biases. And normative biases can be defined in a number of different ways. If we want to follow one of the classic papers in the field by Friedman and Nissenbaum, they say that a decision procedure is biased if it systematically and unfairly discriminates against certain individuals or groups of individuals in favor of others. And based on, or sort of drawing from their approach, drawing from their framework in that paper, in our work, we propose a rough distinction between two different types of normative biases: technical biases and societal biases. And these are really overlapping categories. So we think of technical biases as essentially problems that occur when you apply machine learning, where you're inducing additional biases that are not present in the data itself. So they reflect some sort of failure to predict outcomes with the same accuracy across, say, different protected groups, which leads to skewed, inaccurate, or unequal outcomes. And not all biases in machine learning can be traced back to that sort of technical source or design choice. So In comparison, we define social biases as any sort of systematic preference to make a positive decision for one group of people or class of objects relative to another. And comparatively speaking, social biases would be very difficult to fix, so to speak, because they're more a matter of politics and perspectives and shifts in prejudices and preconceptions that can take decades to change. They're not the sort of thing that you can fix at the data level. So just to give you some examples to sort of explain the distinction between the two with a bit more detail. The first would be an example of technical bias. So imagine that we have sort of a health diagnosis or a well-being tracking app where what it's designed to do is try to diagnose a patient or give some sort of recommendation for treatment, preventative care, triage, something like that. So for many decades, cardiovascular diseases were considered a, quote, male illness, in the sense that they were more typically attributed to or modeled on male patients than female patients. And so the worry is that you can essentially get that historical bias where we thought of a disease as belonging or being more predominant in one sex than the other. You can pick up that historical bias in the training data, and that can lead to very different recommendations for users based on the gender that they input into the app, because you have this historical classification of cardiovascular diseases as a male illness. So imagine for a second that you have a male and a female user with identical symptoms. An app that is trained on that sort of biased historical data may suggest to the female user that her symptoms of having pain in her left arm and back, which in a male patient might be taken to indicate a heart attack and therefore an emergency, may instead be attributed to depression. And the app would then advise the female user to see her doctor in a couple of days, rather than to seek immediate care or to go to the hospital right away. That would be an example of technical bias, where essentially you are picking up this historical bias in how we classified or examined diseases, and then that gets picked up when you were training the model. Another very recent and sort of very publicized example of technical bias would come from the Coded Bias documentary on Netflix, where they talk about bias in facial recognition systems. And what they discuss in that documentary and in the underlying research is how these systems tend to be biased towards white male faces. The systems that they were discussing, that were trained on sort of this biased training data, were less reliable for identifying people who were not white men, in particular Black men and women. And as a result, I mean, you may think that, okay, accuracy in facial recognition, because of the potential usage of that technology in surveillance systems, maybe having lower accuracy could actually be a beneficial thing for a group. But we see, of course, that that's not actually the case. We saw that here in the UK with the trial of facial recognition systems by the Metropolitan Police in London, where Black men and women had a higher chance of being detained, or at least questioned, due to misidentification. Now, to turn to societal biases. So this would be an example of a societal bias. Again, this is a case where the trouble stems from the person that is making the decision or has made a decision in the past. And then that sort of decision rule or the trend in those decisions over time flavors the data you use to train the model and then the resulting decision. And so this is a study from 2017, where it was a study of the effect of the perceived ethnicity of a name on a resume when submitting that to a job. In other words, looking at the callback rate as it functioned according to the perceived ethnicity of the applicant's name. And in that study, the callback rate was 50% higher for applicants with white-sounding names than equally qualified applicants with Black-sounding names. This was a study from 2004. This is a report that references it from 2017. But it's just to say that a societal bias would be, in this case, something where there's a historical tendency, again, to decide in favor of one group over another. And then if you have a CV or a resume screening app or a job application screener, which is a very common usage of AI now, you can very easily pick up those historical biases and end up being having a model that is biased towards certain, again, perceived ethnicities in terms of the name of the applicant. Now, the last example I would give here of a societal bias, this would be a very straightforward one when we're thinking about non-discrimination law. So if a person is only given a job or rejected from a job because of a legally protected characteristic like disability, that would be an example of a societal bias. And we'll get into the law, how it treats legally protected characteristics, and sort of the role they play in both indirect and direct discrimination. But just to say that would be an example of a societal bias. And I don't mean to suggest that the distinction between technical and societal bias is clean. It certainly isn't clean. These things overlap. The idea is that they inform each other. So there are underlying social reasons and inequalities that can help explain, for example, why we don't have good data, why we don't have data of equivalent quality for women or Black, Asian, and minority ethnic people when compared with data for white men in, say, medical research. Again, there will be underlying social reasons for why facial recognition systems have been mainly trained on data sets consisting of white faces or white male faces. But the distinction between technical and societal bias is helpful because it helps focus your mind on what it is you're trying to fix. So are you trying to fix the technology itself, or are you trying to fix society? And that brings us back to those three paths. Are we just trying to not make things any worse, or are we actually trying to use technology as a way to help fix some of the biases and inequalities in society? And we will see that that is mirrored in the fundamental aims of non-discrimination law. So that's what we'll turn to now. Now, EU non-discrimination law, and again, this still applies to UK non-discrimination law until it diverges from the European standard. The law is about fixing society. Fairness is a central concept to it. But what does fairness actually mean in principle? So to start out, we can go back to Aristotle. The law thinks everyone is equal. That is a principle that goes all the way back to Aristotle. You treat like cases alike, you treat unlike cases differently. But the question is, what does equal treatment actually mean? So if in the first instance, the law thinks of everyone as equal and treats everyone as equal, what does equal treatment actually mean in practice? So this is an example here that's we used in the paper and that my colleague Sandra Wachter came up with, and I think is fantastic for explaining some basic distinctions within non-discrimination law and how it conceptualizes equal treatment. So this is the case of the wise judge. The case here is that you have a brother and a sister who are fighting over a cake, how to divide a cake. They can't decide, they can't agree on how to actually cut the cake evenly. So they seek the advice of a judge to solve the problem. And the judge's solution is that the brother cuts the cake, but the sister gets to choose the piece. And at first glance, that's a very, very elegant solution to the problem of making sure everyone gets an equal share, to the problem of equal treatment. But the potential problem here is that the solution ignores the context of the choice, which in practice may significantly impact on what we actually think is fair. So if, for example, the brother has literally just had a piece of cake, just eaten a piece of cake, or if I told you that the sister has not eaten anything in several days, would you still consider equal slices of the cake to actually be fair to both of them? And that example sort of perfectly maps onto this first fundamental distinction in non-discrimination law I want to talk about, which is the distinction between formal equality and substantive equality. So formal equality means you treat everyone the same. You don't consider the differences between people. Everyone gets the same size piece of cake. It's essentially, if you're familiar with fairness approaches in machine learning, it's essentially a fairness through unawareness or a fairness through blindness approach. So for example, you choose to hire everyone with a GPA, grade point average of 4.0, so perfect grade point average, and you don't pay any attention to the distribution of protected classes in your applicant pool. You set a attribute and you say, this is what we're hiring everybody on, and you don't look at protected classes. Substantive equality, in contrast, tries to create a level playing field for people, which takes into account their differences and historical inequalities. And there's two major flavors of substantive equality to think of here. The first is equality of opportunity, which is an approach where you don't ignore the differences between people, but rather you use different or additional criteria, or you give different weights to your existing decision-making criteria in order to create equal opportunities for all people involved, or for your whole applicant pool. Essentially, you're creating a level playing field between your different groups of people in your applicant pool, which accounts for historical inequalities. So some would get a bigger piece of cake because they are more hungry. Now, equality of opportunity does not guarantee that, say, more women would be hired than men, or it wouldn't guarantee that you have a certain ratio of female applicants hired versus male applicants hired. Rather, what you're trying to do with equality of opportunity is to create a decision-making process or an application process that is fair to all candidates, taking into account their differences. Equality of results is the other thing. So equality of results looks for parity in results. For example, by ensuring a 50-50 split of Catholic and Protestant police officers in Northern Ireland, which is an actual split that we have for historical reasons. It's a legal type of positive action where quotas for hiring can be set to achieve equality of results. In the US, you might call it affirmative action, and it's the most substantive, or it's the most common type of substantive equality that's sought within a American legal framework. And so there's this great quote from Lyndon Johnson in 1965, giving a commencement address at Howard University, where he talks about the difference between substantive equality and formal equality, not directly, of course, but he says, "You do not take a person who for years has been hobbled by chains and liberate him. Bring him up to the starting line of a race and then say, you are free to compete with all the others, and still justly believe that you have been completely fair. Thus, it is not enough just to open the gates of opportunity. All our citizens must have the ability to walk through those gates." So the idea is you can't just put your hand over your eyes and treat all the people in your applicant pool the same and still justly believe that you have actually been fair. You have to take these historical inequalities into account, at least if what you want to achieve is substantive equality in practice. Then the next question, of course, is how do those fundamental concepts actually align with the, let's say, main mechanisms or the main sort of protections that the law actually offers? And, unsurprisingly, the two concepts are built into the core protections of non-discrimination law. So on the one hand, you have direct discrimination, which aligns really well with formal equality. The idea here is it's any type of less favorable treatment that is explicitly based on a protected characteristic. So if I do not hire you because you have a disability, that would be an example of direct discrimination. I'm giving you less favorable treatment because of a protected characteristic. And that sort of treatment would be illegal unless the law explicitly allows for it. So for example, if you have a case of a genuine occupational requirement, then you could potentially do it and it would not be illegal. On the other hand, you have indirect discrimination, which aligns really well with substantive equality. And so the idea here is it's any sort of disproportionate adverse impacts on a protected group resulting from a seemingly neutral provision, criterion, or practice. So the idea is you have some sort of process, you have some sort of criteria that seem neutral on the face, but then when you actually look into the impact they have in practice, it turns out that it's disproportionately adverse for a particular protected group. It has to cause a particular disadvantage for a protected group compared with non-members of that group. And that would be illegal unless it's based on a legitimate aim with proportionate and necessary means. And of course, this idea of legitimacy, proportionality, necessary means, these are all legal terms with fairly deep meaning, which I'm not going to go into here. But the idea there is that if, for example, I set a height requirement for my job, so I say that you have to be above 6 foot tall in order to be hired for a job. On the face, that may not seem discriminatory, but if we look at statistical evidence that suggests that men in, say, the UK are on average a certain amount taller than women, or the average height for men is much higher than for women, then that could actually be taken as disproportionate adverse impact on women, even though it seemed neutral in the first instance. And so indirect discrimination differs from direct discrimination because what it does is acknowledge the social hurdles, the struggles, the factual differences that face protected groups. So indirect discrimination was created to achieve substantive equality in practice. It exists to help dismantle underlying power structures in society, to dismantle these criteria that on the face seem neutral, but are actually not neutral in practice. You can think about it really as a tool to detect discrimination in cases where inequalities are not obvious or self-evident. If outcomes are not equally shared across relevant protected groups, indirect discrimination is designed to tell you that that is a place where more social engineering needs to occur if you want to achieve equality of opportunities or equality of outcomes. So the underlying assumption of substantive equality is that everyone is equal. And if outcomes are not equally distributed across your protected groups, it means something is wrong with your system, your decision-making system, your criteria, not with the people that are actually served by your system. That doesn't mean that your system is necessarily discriminatory, but rather that the decision maker, the designer of the system, needs to justify the existence and legitimacy of that inequality of outcomes via this thing called a proportionality test, which again, we won't go into here. That, of course, leads us to the question, what factors could actually justify inequality between groups if we're talking about indirect discrimination? And the key thing to mention here is that it can't purely be economic reasons. So your justification for having a height requirement can't be, well, my business will make more money if I set that height requirement and therefore it's okay. It can't just be economic reasons. There has to be some other reason to justify the inequality, like environmental protection, protection of ethnic and cultural minorities. There's a number of different things that you can use to justify it, but not just solely economic reasons. You can't just say, well, our business model is discriminatory, but it's our business model and it makes us money, therefore it's fine. Interestingly, that is a acceptable defense in the US. Not a blanket acceptable defense, but it is at least in the first instance seen as a acceptable justification of inequality between groups. So what we found in our paper by reviewing theoretical literature on EU non-discrimination law, by reviewing the jurisprudence of the European Court of Justice, is essentially that substantive equality is the fundamental aim of European non-discrimination law. The law is there to help you do, the non-discrimination law exists to help you do things like dismantle inequality, to redistribute resources from the advantaged to the disadvantaged, to achieve equal distribution of social goods for all people, not just groups that have been historically disadvantaged. And the key thing here to take away is that if substantive equality is the fundamental aim of the law, that means just closing your eyes, walking down that second path as a developer of an AI system or a developer of machine learning, and just trying to make sure that your system doesn't make things any worse than they currently are, is not good enough in the eyes of the law. The law demands that you do more than that. What it actually demands in practice is a much bigger question, which we'll touch on, or I'll touch on towards the end. But as a sort of first finding, it's that just walking down that second path is not defensible under non-discrimination law. The law is there to help fix inequality in society, to make society more equal by achieving substantive equality. So that brings us to the second bit of this question, which is how does that fundamental goal of non-discrimination law align with the goals that are pursued in work on fair machine learning? So how does it align with the technical work in the field? What does fairness actually look like in technical terms, according to the machine learning research community? So in the paper, what we did was we reviewed the most popular ways of measuring fairness that have been proposed in the fair machine learning literature. And based on our review, we created a classification system for fairness metrics. Again, by fairness metric, I just mean a mathematical way of measuring fairness. And this classification system is based on how different metrics deal with societal bias. and thus how they align with the aims of non-discrimination law. And it's based around this notion of conditional independence, which again, I won't go into here, but it's covered in more detail in the paper if you are interested. And so we distinguish between metrics based on the concept of bias preservation. So if you have a bias preserving metric, essentially you have a metric that treats the status quo as a neutral starting point. It doesn't question the acceptability of the biases that you have in your training data. Rather, what it's trying to do in practice is just match error rates across groups. So you check if the false positives and false negatives occur at the same rate in the past, in the sense of in your training data, as they do now in your production data. What you're trying to do is preserve the error rate and just not make things any worse than they currently are. In contrast to that, so that's one class of fairness metrics that basically treats the status quo as a neutral starting point. The other class would be bias transforming metrics. And bias transforming metrics would, in principle at least, be a much bigger group of metrics, but in practice, it's the smaller of the two, because it's all other tests. The key difference between the two different types of metrics is that bias transforming metrics are satisfied by matching decision rates between groups, not error rates between groups. And so just to summarize the difference between these two things, bias preserving metrics are seeking to replicate error rates found in the training data. They're trying to match the error rates in the training data with the error rates and the outputs of the trained model. They're treating the status quo as a neutral starting point for deciding what is actually fair in practice. And in doing so, they take the existence and the justifiability of social bias and inequality as reflected in their training data for granted. In contrast to that, bias transforming metrics don't blindly accept social bias as a given or as a neutral starting point that should be preserved, but rather what they demand is that the person, the developer, the person applying the metric or training the system actually makes an explicit choice about which biases are acceptable or which biases the model should inherit and the model should exhibit when it is producing outputs. And this, it's kind of it's a difficult classification scheme for a couple of reasons. One is that bias preserving fairness metrics do seem intuitively sensible in the first instance. So say you want to make loan decisions, it would not seem unreasonable to say, if I want to make good loan decisions, what I'm going to do is look at historical loan decisions and see how people have repaid their loans. If I want to find a good loan applicant now, or I want to assess whether somebody's a good loan applicant now, it makes sense to look at the past. I'm going to look at whether similar people to my applicant have repaid their loans in the past. Similarly, for university admissions, you see if you want to know if somebody's going to be a good student, predict if somebody's going to be a good student, you look at whether similar candidates have done well on that particular course in the past. And you can say the same for job performance, for illness, for health insurance. Effectively, what you're doing when you do that is assuming that there is a reliable ground truth that you can base your decisions on, and you justify the future with the past. You use the status quo as a neutral starting point to make good decisions, to make fair decisions. The problem with that, of course, is that the status quo is far from neutral for most people. You have rampant inequality in societies across the world. You have protected groups that have face considerable discrimination and bias and inequality every day. And by using the status quo as a neutral starting point, what you're doing is effectively saying, look, those inequalities that already exist are fine, they're justified, we're just not going to make things worse than they currently are. And that somehow feels a bit short-sighted, or it somehow feels unsatisfactory if we have the opportunity to use AI systems to actually really critically examine fairness and bias and inequality in society, but our goal is actually really, really low. Our goal is just to not make things any worse than they currently are. Somehow, I don't know, it feels incomplete to do that. And so you have bias preserving metrics, which again, on the face, seems like a fair approach. It seems like something that you would the thing that you would try. Of course, I'm going to look at the past to see how other people have done in terms of repaying loans or done on their just based on the past. Then you're going to end up walking down the same sort of path and still having the same sort of inequalities. And so I had some examples here of just examples of how the status quo is not neutral and how we end up getting these biases in our training data. I already mentioned the white male patient as being a problem in terms of representativeness in medical data sets. But I'll skip over these just in the interest of time, because I think the point is made that, of course, society is not equally great for everybody. Of course, the status quo is not neutral for everybody. So the question is then, how do we reconcile fair machine learning with the law? How do we bridge the gap between these two things? How does technical fairness actually align with the law? Can technical work on fair machine learning, fair AI, actually support or meet the substantive aims of the law to try to address and fix inequalities in society? In other words, can fair machine learning actually achieve substantive equality in practice? And again, so these are this is the distinction that we had between the two, and unsurprisingly, we can see how bias preserving metrics map better onto formal equality, whereas bias transforming metrics map much better onto both formal equality and substantive equality. So bias preserving metrics are more akin to formal equality, or the idea of not changing things or correcting for existing inequalities, whereas bias transforming metrics are more akin to substantive equality, the idea that changing things or actually addressing existing inequalities is what you should be doing. So I suppose the final question to ask here is just exactly how prevalent of a problem, and I'm going to call it a problem, how prevalent of a problem is bias preservation in work on fair machine learning? Is this just the case that we have a couple of ways of measuring fairness that are bias preserving, but actually most of the work is bias transforming? Well, what we found by applying this classification scheme to the 20 most popular fairness metrics in the literature is that bias preserving is a much bigger group. That is, it is the more popular approach. So these are the 20 most popular or most cited, let's say, fairness metrics in the literature. And we applied this scheme to them. And what we found was that 13 out of the 20, or roughly 2/3 of them, are bias preserving. And that's a really, really significant finding, because using bias preserving metrics to make decisions creates a legal problem for deployers of AI systems. If they were ever to be sued or challenged under non-discrimination law, they have a really, really difficult problem to face, because essentially if you can show that in a particular domain or a particular training data set, so let's say you have training data that's based on historical hiring decisions in the UK. If I'm able to show that there was inequality in historical hiring decisions in the UK, and you have used training data based on that, based on those historical patterns to train your system, I've actually already done most of the hard work in establishing that the outputs of your model are discriminatory, or at least are legally problematic. We go into that problem in a lot more detail in the paper, but the short version of it is basically to say that if you are using bias preserving metrics to make production decisions, and you're operating under your European non-discrimination framework, you're setting yourself up for a really, really difficult legal challenge. It's kind of unsurprising, though. I mean, we were surprised to find that 2/3 of the metrics in the literature are bias preserving. But in some ways, it was also sort of unsurprising, because most of the work in this field comes from North America, and is based in a US anti-discrimination framework. And in the US, the fundamental aim of the law isn't substantive equality, or at least that's what most legal scholars would say. It is formal equality. There are people that argue for substantive equality, and you do have some examples of it. But in general, it's not going to be seen as the fundamental aim of the law. So that's a pretty significant difference between the two frameworks. And it would make sense that, of course, you're going to have more metrics that would match up with a legal framework in America. But if you try to apply them in other places where the legal framework is different, where the fundamental aims of the legal framework is different, And again, you run into the sorts of problems that we identified in the paper. So we create a really simple checklist for choosing a type of fairness metric. Just again to explain sort of the significance of the classification scheme and of bias preservation as a concept. And what I don't want you to take away from this talk that bias preserving fairness metrics are just bad across the board or anything like that. It's more that they can be useful for certain things, but I would hesitate to use them for other things. So if you're doing diagnostics, if you're just doing testing, if you're doing research, bias preserving fairness metrics are absolutely fine. I mean, in fact, you'd be encouraged to test your models as widely as you possibly can with as many fairness metrics as you possibly can. Totally fine for that. Or if you're making decisions like who to hire, who to invite for an interview, who to let into university, who to arrest. If you're making decisions in a place where the legal framework is going after formal equality rather than substantive equality, again, those metrics are totally fine. But if you are making decisions in a legal framework where substantive equality is the sort of driving aim, then again, you are setting yourself up for difficulty. So both of these types of metrics have uses. They're very useful for certain things. But the warning here is more around using bias preserving ones under your European non-discrimination law. Now, I mentioned before that what the law actually requires of you in practice is a difficult question to answer. It takes place, or it's discussed under the heading of substantive equality duties. And the thing I would say here is essentially that the debate, at least in legal scholarship, is not around whether substantive equality is the fundamental aim of non-discrimination law or not the fundamental aim of non-discrimination law. It's accepted that it is, but the debate is more around what that actually requires of people in practice, what substantive equality duties exist for different sorts of organizations and individuals across different sectors in society. So what role, passive or active role is expected of, say, a regulator, legislators, the private sector, the public sector to actually achieve substantive equality in practice. And it's very much an open debate. It's essentially a political debate. It's a question where the answer will, of course, vary significantly between countries and between sectors within the countries. Maybe we would say that say you have a preemptive duty if you're in the public sector to dismantle inequality. Or maybe we would say you only have a duty to report something if you know that inequality might occur in a given decision-making process. So is this sort of a proactive duty where you are trying to hunt out inequality, or is it more of a reactive duty where if you see something, then you should actually say something about it, or if you have a complaint made, then you should actually do something about it. So that's really where the debate is. It's what do these equality duties actually look like? What do they actually require in practice? And so this was just a slide to summarize the main messages of the paper. But just in the last 2 or 3 minutes, I do just very quickly want to mention the related piece of work that I talked about earlier, which is essentially a follow-on to this work on bias preservation, where, again, the same team of people, myself, Sandra Wachter, Chris Russell, we propose our own fairness metric, a bias transforming fairness metric that we call conditional demographic disparity. So this is essentially an answer to the question of, okay, if I'm going to use a bias transforming fairness metric, which one should I use? What's the best one to use? This is our answer to that question to some extent, as far as you can actually answer that question. And this one is reported on in this paper, Why Fairness Cannot Be Automated, again, freely available, very, very easy to find. And so just to explain I suppose the value of this fairness metric, or why it is that we proposed it. So the thing that we talk about in the paper that I'm not really going to be able to talk about in great detail in the talk, at least, happy to answer questions about it, is that the way that the law is actually applied in Europe is based on this idea of contextual equality. what that means is that you won't have a consistent standard of equality or consistent standard of legal disparity. So if you've heard of, say, the 4/5 rule, which is a rule of thumb in US anti-discrimination law, where it's basically a threshold to say, when a decision or when a set of outcomes is problematic or not problematic, we tend to not have those sorts of clear thresholds in jurisprudence relating to non-discrimination law. So you're not going to get a clear steer that says, like, as long as you hire 80% as many women as you do men, then you're fine. You're not going to be in violation of the law. Rather, the way that equality is measured in European law tends to be much more contextual. It's based on like intuitive measures and tests and lessons from historical examples. You even identifying the group that you're comparing yourself with, because you have to be able to identify the outcomes you received as a protected group versus another group. Even that's really hard. I mean, if we're looking at hiring procedures, say at the University of Oxford, who am I comparing myself to? Am I comparing myself to all other applicants for a given job? Am I comparing myself to all people who could have applied for the same job as me? Am I comparing myself just to people with certain demographics in the applicant pool? Like, it's as much a debated question around who you compare yourself to as it is what the threshold should actually be. And we don't have standard evidence either in European law. So it's just, I suppose the takeaway here is that the way the law is actually applied in Europe is not straightforward. It's not going to be something that's easily measurable. It's very, very contextual. And yeah, these are just going to cover that. But basically what we did was look at the European Court of Justice's gold standard for comparing groups to one another. And what they said in one of their cases is that the best approach to the comparison of statistics, so comparing statistics for outcomes between two different groups, is to consider, on the one hand, the respective proportions of men in the workforce. This was a case that dealt with hiring. Men in the workforce able to satisfy the requirement of 2 years employment under the disputed rule, and of those unable to do so. And on the other hand, to compare those proportions as regards to women in the workforce. So the idea is that the gold standard that the court has set for itself is that the composition of both the disadvantaged and the advantaged group must be examined. And so we proposed our fairness metric basically as a solution to the question or the problem that comparison creates. So the problem here is that if you want to use fair machine learning, or if you want to use fairness metrics in a way that supports the judiciary, supports how the law is actually practiced, how it's actually applied. Basically, if you want your fairness metric to line up as well as it possibly can with how the law is currently applied in Europe, how do you do that? And that's what our fairness metric is designed to do. It's designed to match up as well as you possibly can with the European Court of Justice's current approach. And again, sorry for not being able to get to this, but we go over the sort of implicit fairness metrics that the court uses in its jurisprudence. We show some problems with them, and then we explain how our fairness metric, conditional demographic disparity, how it is a better match with the way the court currently applies the law in, let's say, an offline world, or in a world where we're not dealing with automated decision making or cases involving AI. And so what we propose is that essentially you use this fairness metric to create what we call summary statistics that give you as broad a possible view of the outcomes, comparing outcomes between groups within your sample. So there's different ways to basically slice up the groups that have received a decision from your system or received a job offer, whatever it may be. And what our metric is designed to do is give you as broad a possible view with as many possible groups or different slices to help you identify where there is actually disparity between groups, and disparity that is meaningful, is significant. So we like to think of it as a sort of treasure map. Like the metric is there to help you find inequality, to help you find indirect discrimination, potential indirect discrimination between groups where it may otherwise not be noticed with other sorts of metrics. And just to close, so that metric that we proposed, it's been picked up in a number of places. It's in a number of reports here in the UK. Center for Data Ethics and Innovation talked about it. The European Commission, World Economic Forum has talked about it. But if you are a machine learning practitioner and you use Amazon Web Services, they have an interface for Amazon Web Services called Amazon SageMaker Clarify, where essentially what it is a interface you can use to test your machine learning model for bias, for fairness. So they've implemented that fairness metric in that interface. So if you wanted to actually see how this thing worked in practice, it is available to be used there. So I'll end with that. Thank you so much for your attention. Sorry for taking a bit longer than I originally wanted to, but I'm really looking forward to our discussion, and thanks very much.
All right, that was great. No need to apologize at all. That was fascinating. I know we got some comments in the chat about people wanting to know where the paper was. They want to read more about it. Before we get to Q&A, can we just do what we typically do, which is for everyone to unmute and clap? We'll do a round of applause.
Thanks. I haven't had that before. I like that idea.
It's the best we can do these days. So we haven't gotten a huge number of questions in the chat yet. I have a long list of questions, but I don't want to be the only one asking questions. So I'll take one question that's already in the chat while people think of their questions. The first one, which I imagine you get a lot, but it would be helpful to clarify how substantive equality relates to equity.
Yeah, so I assume that I assume you're using equity in like the American anti-discrimination sense.
Well, this is a question from Alice. So Alice, would you like to come on and clarify?
Hello. Yeah, so only because the distinction you made between, I've made so many notes I can't find it now. The distinction you made between formal and substantive sounds a lot like the way it's used in some papers I've read between equality and equity. But you did go on after I'd put my question in to explain it in a lot more detail. So I think the answer is yes, but it's way more complicated than that. But I'm happy for you to give a better answer.
No, that's absolutely the correct answer.
Okay,
yes,
cool.
they are similar, but they are definitely identical.
Yeah, okay, cool. Thank you.
Okay. Question from Jasmine here. Jasmine, do you want to read it out, or do you want me to read it out?
I was going to say, do you want me to just say something?
Go on, jump in.
Yeah, so I guess I'm thinking about the data that's underlying the models and how you go about identifying advantaged and disadvantaged groups. Like, just that notion itself has the potential to be biased. And particularly, I'm thinking about contexts where people are missing entirely from the data that are motivating these models. But also thinking about context in terms of how you identify disadvantage. So, you know, if we think about women as being a group that we often talk about as being disadvantaged in a variety of contexts, in infertility data in the US, for 50 years, they only surveyed women. So it looks like women are doing great in infertility data, but actually that's reflecting the fact that all of that reproductive expectation is being placed on women's shoulders, right? So it's still a form of disadvantage, but they're there in the data. So how do you work with that notion of disadvantage just based on who's in the data and who's not?
Yeah, that's a great question. And sorry, it takes me in like 3 or 4 different directions, so I'm going to inevitably forget some of them, but maybe we can come back for a response too. Yeah, so that question of representativeness in the data itself and sort of the bias that you can have from how the data is collected and just the history of it, how it's been cleaned, you know, how you deal with things like missing data points. Those are all really, really important questions. It's not the sort of thing that the fairness metrics I was talking about would deal with really, because they're more about like measuring disparity in outputs of a system, but they are sort of just as important. If you're going to answer the question of what biases should my model have, you need to know what the biases are in your data set to be able to answer that in an informed way. And so you need to establish things like the history of the data, how it's been collected and curated, and ideally capture that in such a way whereas, you know, somebody that's coming onto the data set at a later time is able to also make an informed decision about it. Now, the point you made about advantage and disadvantage groups, which I kind of glossed over in here, is a really, really, really difficult question because for a couple of reasons. One is that I suppose one of the things that inspired us to write the paper is that we thought it wasn't right that the people who are deciding what the disadvantaged group is and what the advantage group is the developer or the user of the system. And the reason we thought that was problematic is identifying both those groups is a significant point of contention in cases under non-discrimination law. So just as much of those cases are about who it is you're comparing yourself to as it is about establishing the existence of disparity between those two groups. There's a strategy that we picked up on under, sorry, I'm just scrolling through something here. There's a strategy that is used quite often successfully in non-discrimination cases called divide and conquer, where a very simple example of that would be if you have established that there is disparity between men and women for a given decision, one thing that will be argued is actually we shouldn't be comparing men and women, we should be comparing men to Black women. So you have essentially intersectional discrimination. And that's used as a way to not to make a stronger case, but rather to make the inequality disappear in practice. So if you can divide your comparator group up in such a way where the outcomes that a particular group received don't look that bad compared to the other group, you've managed to make the inequality seemingly disappear in practice. Whereas if you were comparing the original groups that were proposed by the person bringing the case, then the disparity is very, very clear. And so that's why we proposed this particular metric and presented it as like a treasure map, or talked about summary statistics that should be published. Basically, we think that decision around who your advantage group and who your disadvantage groups are is not one that can justifiably be made at the system level or like at the level of the developer or the user of the system. It's something that is a huge point of contention that is decided in court. And we think the best thing you can do in practicing fair machine learning, so to speak, is to give data, give evidence, give statistical evidence, some measure of fairness to the court and to the defendant and the plaintiff in the case, so that they can actually have a informed discussion over the potential advantage groups and disadvantage groups and how you're going to actually divide them up. There's a huge problem right now also, again, in the courts where quite often the defendant, if it's a company, will have the ability to produce really sophisticated statistical analysis that is just not available to the plaintiff. And so this is another idea where if you basically implement a requirement saying, okay, you need to produce a certain type of report that reports on a number of different fairness metrics, and that has to be shared with everybody involved in the case, then you've actually gone a long way towards sort of resolving some of these what I would call it issues around making inequality disappear just by dividing groups up in a certain way. So yeah, that's a long way of saying that basically we thought that people with democratic legitimacy to actually decide who is the advantage and disadvantage group should be making that decision rather than just the person actually doing the fairness measurement or designing the system in the first place.
I have a sort of follow-up to that, which is I was just thinking that, you know, courts tend to work at different speeds to development teams. And so what are the kind of wider methodological implications of this if you were a development team and you really wanted to enact kind of bias transformation approach? Kind of involving the court system seems like a very slow route to go.
Yeah, I mean, to be fair, that can be said of any sort of hiring procedure, anything where you would develop a system to make a decision. The same could be said of like the analog equivalent of that, because you don't know what the outcome of the case will be until you're actually sued, essentially. Now, that's obviously not a satisfying answer. But the thing you can do, and again, why we propose that particular metric, is we think you basically offload the decision around fairness, and you offload it to the level of, I think the initial decision could be taken by the deployer of the system, the company using the CV screening application, for example. But then they would be required to actually report on outcomes using our metric, using a bunch of different metrics, so that basically their outcomes from their use of the system can be scrutinized by other people. So I suppose the short answer, if you're a developer, you should build in the ability to look at the model through as many different metrics as possible, and make it so that it's as easy as possible for a deployer of the system or a user of the system to do this sort of testing in practice. Because ultimately, you're not going to be able to say one way or the other that your system is definitely fair, at least in a legal sense, until you've been taken to court or until you're following some legal precedent. It's kind of infuriating because it's highly contextual, but you can also see why it's highly contextual. So I guess offload the decision to somebody else. Design your system in such a way where it helps other people make that decision rather than making it at the development level.
Well, another follow-up to that then is what do auditors need to see? Or I guess the other way of asking this question is kind of how ready is the kind of AI auditing / regulator community for this kind of approach? Is this new to them? Is there any catching up that they need to do? Just interested, because I know you do stuff around AI auditing as well.
Yeah, I mean, it depends. AI auditing is becoming a big industry. I think it will only become bigger as the AI Act is hammered out and comes into effect. This approach is not, so it's new in the sense of nobody else had drawn that connection between the fundamental aim of non-discrimination law and this work on fairness in machine learning. But the idea that you have lots of different fairness metrics and lots of different ways to measure fairness in practice, that's certainly not new to them at all. You have Amazon that made their interface way before we ever started this. You have Google did a similar thing with TensorFlow. They have the what if interface that achieves a similar sort of thing. So yeah, people are very much aware around the existence of lots of metrics and the need to test, but what you should actually be testing for and which metrics you should use, not just for testing, but also decision making, that's the thing where I don't think anybody wants to hazard an answer to it yet, because it could have really significant consequences if you do. And also, to be fair, with the AI Act, most of the work of actually setting standards around how you test for fairness and bias, that work is still to come. It's been offloaded to standards bodies. So, I think it will come, but we'll see. It may still be a few years.
Okay. There's a question here from Mariana. Do you just want to come in and ask it?
Yeah, I could. So first of all, thank you very much for your talk. That was really fascinating. You mentioned at the start that the data might not be the only answer when we want to tackle inequalities and bring fairness. So based on that approach, I was thinking, if what might be the most difficult challenge when it comes to digital technology, and how can we go about that? How can we respond to that if we're not using data? So what is the thinking behind that approach? Thank you.
Yeah, I don't want to suggest that fixing the data or improving the data is not important. It's really important. It's the first thing you have to do if you want to tackle fairness or make a system that is less biased. You have to look at data quality. You have to look at representativeness. You have to look at completeness. You have to look at biases in data sources. Yeah, I suppose it's more to say fixing the data is more about improving your picture of ground truth. So you can't really make an informed judgment around what is fair or not fair if you don't have a good, reliable picture of the ground truth of the situation. But assuming you do that, assuming you do get a good picture of the ground truth, assuming that you do have good data, the message here was more to don't take that as a sign that you have solved fairness. Don't take that as the end of the road. Rather, that's just the beginning of the path where you can actually measure fairness in a reliable way and actually do it in a critical way. And I suppose the one of the biggest challenges for sure that promises to be a challenge, I think, as long as we have these systems, is the existence of reliable demographic data to do these sorts of tests. Because quite reasonably, most data controllers do not want to collect this sort of data because of the risk that comes with it. But if you don't have data around ethnicity, gender, disability, religious beliefs, political beliefs, all the different things that are covered under non-discrimination law, then actually doing reliable tests, reliable fairness tests, is really, really difficult. And there's the AI Act may deal with this to some extent, or at least propose some sort of solution. There's this vague idea of like a regulatory sandbox where you can do this sort of testing in a safe environment. So we'll see, but that's definitely going to be one of the biggest problems. Because again, I think people, especially people from historically disadvantaged groups, have very good reasons to distrust people taking that sort of data from them, recording that sort of data.
I see. Thank you very much.
We have a question from Jose. Do you want to ask that?
Yes, thank you for the interesting talk. I was thinking that maybe incorporating members of to the teams with that are trained on historical and social biases can be a way to set these rules and not to wait to courts or maybe another kind of organizations that could bring us, I don't know, to wait too long. Excuse me, my English.
Yeah, no, I definitely get the point there. And yeah, I think having people on a team that can look for these things, that are sensitive to, or familiar, have knowledge in historical and social biases, is really important, especially when you're creating training data, deciding which training data set to use. I think just having people with that sort of awareness is a great first step. And yeah, please don't take what I said as a way to like discourage development teams from trying to deal with fairness and bias. It's meant to be quite the opposite. It's more, I've heard anecdotally that, if you are a developer of a system and you're being asked to make it fair, do you really want to be the one that's deciding what is fair and what isn't? I mean, that's a pretty big responsibility. And so that's why I think that second path is so tempting. It's just, we're just not going to make things any worse than they currently are. Just please leave me alone. I don't want to be the one responsible for this. And I can sympathize with that fully. So what we're saying in this is essentially do as much as you can at the development team, as much as you're justified in doing at the point of development. Improve your data as much as you possibly can. Design your system so that it can report in a transparent way the results of these different fairness tests. Make it compatible with the tests essentially, but in saying what is or is not fair, is or is not biased, is or is not justifiable, give other people that are in a better position the evidence to make those decisions, to have those conversations. Don't do that yourself. Sometimes developers will be asked to, and I certainly wouldn't want that position. I'm an ethicist.
Thank you, Brent. Thank you very much.
So we have another question in the chat. Itoro, do you want to ask?
Yes, please. Thank you very much for this interesting topic. It's really interesting. But I've been reading through these all biases and ethical issues, but you've met very interesting points that is really going to help me. But my confusion was this socially constructed biases or technical constructed biases. I don't know, but then because the models would definitely look at the technical ones, but the socially constructed biases, are they going to be addressed by means of legislation or law or whatever? If that is yes, how would that affect the capability of developers, limiting their, in relation to the laws?
Yeah, so I mean, I would say social biases can be addressed in a number of different ways, which would include the law. It can literally just be, changing hiring practices at the level of an individual company, and over time it sort of accumulates, and you have changes in social mindsets or just trends or things like that. But the way that it feeds into a development team, like the responsibility of the developers, I think is more that social biases should not be something that your system ignores or that you ignore in the development cycle. It's more you want to create your system in such a way where you have recognized the existence of social biases that influence your system from the outset. So things like the facial recognition example, we know that the training data sets are very skewed towards the types of people that are actually in the data set. So knowing that there is a social reason for that, knowing the existence of that social reason and then the effect that that ends up having on your data, I think is very, very different, even if you can't go back and do anything about it. Or maybe you can. Maybe you create a new data set that's much more representative that can then be used as a training benchmark going forward. So it may not be that you can fix the entire social reason for why there is a bias, but maybe you can do something to improve the next system or to give an alternative to the particularly biased data that you were going to use. And then on the other side, you want to design your system in such a way where it can be used as basically it is supportive of people fixing social biases, that it helps people to identify inequalities. It helps them to compare them in a fair and transparent and sort of objective way, and to not hide things. So yeah, it's not something you can, changing the design of a system isn't going to immediately fix society. It's more just, it's something that can be a building block, I guess.
Yeah. Thank you very much. That's very helpful.
Yep.
I had a question about trust. I wouldn't be me if I didn't ask a question about trust. But I just was wondering if you've thought about the relationship between kind of the dominance of these bias preserving approaches in AI and public distrust of AI, and whether you think there's that sort of a cause of some of the distrust, and whether adopting a more bias transforming approach would remedy some of that public distrust.
That's a good question. I'll be honest, I haven't thought about that in great detail, but my immediate reaction is that it's probably not that big of a influence on trust or distrust right now. Just because the conversations I see around, really, if you look at media that's reporting anything to do with like bias, discrimination, fairness, and AI, it tends not to be with how we're measuring fairness. It's more about there's a really clear trend in the outputs of a system or the performance of a system that is very clearly biased toward or against one group or another group. It's the thing like the Coded Bias documentary. Can you address some of that with these fairness metrics? Absolutely, but I don't think that's where the sort of public attention to it came about. Now, with that said, I think the next step in all of this is it feels like we've kind of gotten over a threshold of having regulators, having tech companies take fairness seriously in these systems and take bias seriously in these systems. But it feels like the next step is to make sure they're not using it in a dishonest or problematic way. And that's the project you mentioned at the beginning, the project I'm working on right now, the trustworthiness auditing project, is looking at exactly that. It's basically looking at how do you ensure that something like counterfactual explanations or something like conditional demographic disparity is being used in a way where it's not misleading the person, because it's incredibly easy to use these things to mislead.
Cool, that's super interesting. Okay, because I was just thinking about, sometimes there was a paper in fact last year that was the title was something about I agree with the decision, but I don't believe they deserve the outcome, something like that. And it seems like there's a relationship there between how people they'll recognize that, okay, well, it's technically, yeah, it's fair, right? But something about people deserving what they get, that relates a little bit to people's sense of fairness, insofar as it bleeds into matters of trust.
Interesting. Could you send me that paper? I haven't seen that.
I could tell you it's by Casinadu, but I'm not pronouncing that correctly. But yes, I can send that to you after.
Thank you.
Does anybody have any further questions? We've had a really great discussion so far. If anyone has a last minute question, now's your chance.
And I'll have 5 minutes more in the nice weather.
Well,
or down here, it's nice.
Looking out the window, it's just clouded over, but I think it's pretty nice here. Well, I know I have tons more questions, but I have to formulate them coherently and then maybe send them to you, Brent. So let's see. No other questions. Okay, so I think we'll end there. Thank you to everyone who joined us today and asked questions. So I know that in the DSI, in the society theme in particular, we're going to hopefully kind of carry on this discussion in our inequalities theme, and also to the extent that it's relevant in the trust in AI theme. Everyone's going to go and read your paper now. So thanks again to Brent. Can we all do the clapping thing again? So everyone unmute and clap.
Sure.
Thank you, everybody.
All right, well, thank you so much again. Julia, you may finish